everyone, my name is Ashta Gupta and in this video we will learn about Pandas library in Python. So for the introduction, Pandas is an open source Python package or library which is widely used for data manipulation and analysis tasks. It is a vital tool for data analysts in today's world. It is built on top of another package called NumPy, which has already been explained by my partner Ria in previous video. The main data structure in Pandas are implemented with series and data frame classes. So first we'll learn about what are these data structures. So series is a one-dimensional array with indexes. It stores a single column or row of data in a data frame. While data frame is a tabular spreadsheet like structure representing rows, each of which contains one or multiple columns. A two-dimensional data structure is a two-dimensional or more kind of data structure is what is contained in data frames. So first we'll start by importing pandas, and we are also importing NumPy because sometimes we'll use NumPy. So we'll just write import pandas as pd. Now you can use any name for the keyword. Here I'm using pd, but if you want to use as pandas as pand, so you can use that as well, but here we'll go with the short form pd. And for NumPy, I will use NumPy as NP. I will run this code. So first we'll start learning how to create the series. So series will create by using functions called random. Random function is a function which will call upon random numbers, which will directly be chosen by Python itself. So we'll name our series as ser equals to pd dot. Now the code word for calling series is capital S and series. We'll see we're using np over here, and then random np dot. Now we want only 10 random values for our series, so we'll write that and when. Now you can see here it starts from 0 to 9. So we have called here 10 numbers. So it starts from 0 to 9, which are 10 data values over there. Now to verify whether this thing is actually a series or not, we'll write type ser. That is our series name. So here it shows pandas.co.series.series. It means that this data frame, which is called as this data structure, this data structure which is named as ser is series. Now how to form a data frame? To form a data frame, we'll first define a dictionary. Dictionary is basically nothing but a set of values stored in relation with the keys. So to form a dictionary, we'll use this. We'll define our key as name, then we'll go with the colon, square bracket, and then we will define our elements. For example, here we are defining marks of our various classmates. Priya, then the next key is marks. Sorry, I'll just I'm just putting random numbers over here because we don't have actually set of values, so we are creating a dictionary by our imaginable values. So the next I will write as classes, class which they belong to, column, this. We define strings under this inverted commas, and for these which are integer values, we just describe it as it is. We're done with the describing a dictionary. Now we'll just check if everything is right, and then we'll call for printing a dictionary. We have named our dictionary as dict1, so we'll just write dict1 over here. Oh, there's an error. It's not defined. Oh, I'm sorry, I have used question mark over here. Now if we run this, so here we have our dictionary. Now we'll insert this dictionary into our data frame. So we'll call our data frame as dfpd dot. Now the keyword for calling a data frame in pandas is dataframe, in which we have capital D and F. Now we've inserted our data frame as a dictionary, and now we'll call df. Here you can see a tabular format of presenting our data. So this is similar to what we can see in Excel and spreadsheets. So this is our data frame over here. Now this is a bonus point, importing in CSV. You might be familiar with this, that we import CSV files in pandas to work on those files. But here we can also make CSV files in Python, like in pandas already. So to import a creating CSV. So to create a CSV over here, we'll use this code. df dot to underscore CSV. We'll name the CSV as marks underscore marks again dot CSV. Now I'll close this. I think I've used okay. Now if we run this, we can go over here and type here marks underscore marks. See, we have created a data frame in Python. This is the data frame that we've created here. This goes here. But now we can see that we have this extra indexing format over here. We already have 1, 2, 3, 4 numbers over here, since the data format of the spreadsheet is like that. But we also have this extra index over here. So we'll remove this default indexing using this code df. So to make any changes in the CSV, we'll have to create another CSV file. So we'll say df.csv to CSV. We'll tweak a bit in the name. 1 marks. Instead of writing marks, we'll write index false, because we have removed our index. The default index, they put it. And the code to actually remove the index is index equals to false. Now false is a Boolean data type. So we've used this, and then if we run this again, what does it give us? .csv. Here we have another data frame. It has created this data frame, and as you can see, it removed the default indexing that was there previously. So we created this data frame at first, but then we removed this indexing, and here we don't have any indexing. So this was the bonus thingy, just to let you know that we can also create CSV inside pandas. Now we'll use the first function head. This function returns the first n rows of the objects. Like if suppose you have 554 rows and 300 columns of data. Okay, so your data frame contains 554 rows and 300 something columns. It is a very large data frame. So to have the first, just to have a look upon the first few values, we used head. Now if I use head, the code is df.head. It is very simple. Now I get all the values because I have already very less number of rows and columns over here, so it gave me all the values. Now how to specify that I only need this first few values? So you write df dot head, and in this bracket which we used over here, we didn't put any number over here, so it by default gave us output of first few data types. But now I only need 2 rows of values. So here you can see they've given us 0 and 1. Similarly, we can use tail to give us last few columns of data, last few rows of data. Now in this also they have given us all the data because our data is very small. We'll run this again in some other data, but here I just want to show you guys that we can call upon specific number of data as well. So here they have given us last 2 rows of data, so it is 2, and here the head was 2, so they have given us specific number of data. Head is used for the from the above data flows, and the tail is used for the below data structure. And now the third function is describe. Describe returns a statistical analysis of a data frame, but keep in mind that they'll only return you the numerical values. Like if I use this code df dot describe, they've given us only the data statistical analysis of marks, because marks is the only column which contains numerical values. They won't make statistical analysis of name or class, because those values, the values that they contain, those columns contain, are string values. So we cannot make data analysis like statistical analysis of the string values. So this describe can be used only for the column or for the data values which are numerical in nature. So here they have given us count, mean, standard deviation, minimum, and various other kind of statistical analysis. The next function is indexing. Find the index position of an element. So with the help of indexing, we can find the index position of an element. In pandas, the indexing starts with the number 0. So the first row or column which you'll have in your data frame or data structure of any type, the first number or the first column starts from 0. So if you want to say point out the first row and the first column, you'll have to use 0, and the second it's 1, and then 2, and then 3, and then 4, and so forth. So here we are trying to add index number, like index value to this number. Here you can see that it starts from 0. Alright, this is default indexing. Now we'll turn it into df.index equals to, in square brackets, 1 2 3 4, because we have 4 rows. And now if I print df, see, it changed into 1 2 3 4. So it started from 1 2 3 4 because we asked it to start from 1 2 3 4. Here we have indexed using integer values. 1 2 3 4 are integer data types. Now what if I want to, instead of 1 2 3 4, I want to use strings? So for indexing you can use any type of data, strings, float, boolean, not boolean, yeah, boolean also maybe, strings, floats, whatever you basically want. Dot index equals to, now here I'm inserting my index values. So first should be 1, then comes 2, then comes 3, and then comes 4. You can use any word, whichever you want. Now if I print df, see, it changed to 1 2 3 4. So basically what I'm trying to make my point over here is, you can use any kind of data type to make your index column. 1 2 3 4, 1 2 3 4 in words, or whatever you want, even timestamps if you want, whatever. Now we'll continue to learn more about this using another data frame. Continue this, we'll create another data frame. I'm creating new data frames just to bring in the effect that we have different types of data structures. Like we started with a small data structure, then we moved to a larger data structure. Now we will move to a way more larger data structure. So now I'll just create a new data structure by defining it as new df equals to pd dot data And this data structure will allow us to implement more codes or more functions. Here we are again defining, we're using random function just to call upon random numbers. Basically we are using 334 rows and 5 columns. This will make a good amount of data over there, so we'll be able to work with a comparatively larger data. Now I'm using a new word over here, which is arrange. You must have learned about it in NumPy video. Arrange is nothing but a very basic function which allows the pandas to make evenly spaced values. So when we'll create this, we'll have evenly spaced numerical values as our data points. So now I'm running this. Okay, PD is not defined. Oh, we'll have to run this again. Okay, now I hope so it's defined. Okay, here we have our data frame. Just to verify this, if which data structure type it is actually, we'll go insert over here so we can see that it is data frame pandas.core.frame.dataframe. So it has been verified that it is a data frame structure. Now, as earlier we could not see, when we used to use head function, we just got all the data frames. Now if we use head function in this data frame, we'll actually be able to get the desired results. Like I was telling you that we will get only first few rows or columns of data. This is how head function works with the larger amount of data. Same goes with the tail function, new df.tail. Now here we have bottom few values, like the last values. Now we will just see if the data types of all the columns or series. So we will write new df.dtypes. This will give us the data types containing in each column. So the 0 column has float data. As we can see, all of this is 0.1, 0.7, etc. So this data type is called float. So 0th column has float data, first column is float data, etc. etc. Next we'll learn about sorting with index values. So here we need to have a clear idea of what axis is, because we'll use axis. So axis equals to 0 is basically a reference to the rows of data frame, and axis equals to 1 means column. Now if we use the code for sorting, it's new df.sort underscore index, because we will be sorting through index. So axis equals to 0. Now if I just apply this much, I'll get the same data, because here I've written sort axis equals to 0. Axis means rows, but in default case it arranges the value, it sorts the value in ascending order, and since it was already in ascending order, it just gave me the same value. Now if I, instead of doing this, makes a change ascending equals to false, so I'm asking it to not make it in ascending order, rather make it in descending order. So here, as you can see, it has arranged rows in descending order, because I have written here ascending equals to false. Now if I use this same code with axis equals to 1, it should arrange my column in descending order, because I have written ascending equals to false. So we have got 4th, 3rd, 2nd, 1, 0th column likewise. Now just remove this extra thingy. Now we'll see if we can locate something. And I'm just writing 0. See what has it given me. So it has given me 0th column over here. So we've located 0th column. Now we'll verify if what data structure this belongs to. Okay, so we'll write type We'll copy this over here, paste it. See, series. Now to recapitulate what series is, as you've learned already, but I just wanted to give you, a practical application that if you want to have this particular access to this particular column, what that specific column means. This specific column means a series data structure. So by combining different types of series, we make a data frame. Alright, as this was the series, this zeroth column itself was a series, and then first column is a series. The combination of 0, 1, 2, 3, 4 column is what formed a data frame. So here we verified that only if we talk about the zeroth column having the same data values, which is float data type, same data values, not same data type, it makes a series value. So if we look over here, it is a one-dimensional array with indexes storing a single column or row of data in a data frame. So this is one-dimensional data structure, which is called series. So we have verified that also. Now moving ahead, now we will describe lock and iLock. We'll learn more about lock and iLock. So it is a very important concept in pandas. So we'll start by defining what is actually lock. Lock is a label-based data selecting method, which means that we have to pass the name of the row or column which we want to select. So lock is basically if I name my column as A, B, Harry, 1, 2, like different data type, if I label my column with that name, I'll use that specific name to extract that element that belongs to that column or that row. I'll not use 0, 1, 2, 3. If the name is 0, 1, 2, 3, then I'll use it 0, 1, 2, 3. But I'll not use the index, the default index that we give. We'll learn more about when we go to application or implementing the codes. Now, iLock is indexed based. So it will only allow index values to function. So if I want to access first column and the name of that column is A, I cannot use A. I'll have to use 0 because the indexing starts from 0 and I want to access the first column. So I'll have to use 0 instead of 1 or whatever the name that column has. I'll use index values. Now the significance is lock is label based and iLock is position based. Position basically means indexes, which starts from 0 in rows also and in columns also. It's very important to know that and to remember that. Now what if I want to use lock? Now first, since we have this data frame as 0, 1, 2, 3, 4 this side on this side also, I'll just change the column names so we get a clear view of what is happening, otherwise we might get confused. So to change the name of this column, I will write the code new df dot columns equals to list pcde. Since we have specific number of columns, we'll use a list of that one. Now here in this code, what I'm doing is I'm referring a list of A, B, C, D, E to the columns. So it won't name column 1 as A, B, C, D, E complete. It will change the values like A for one column, B for the next column, C for the next column, and henceforth. That is why we have inserted a list. That is the property of a list. It will change with values. Oh, I'm sorry. If I print this, see, the column names are changed. Now we will use lock. Now here we are trying to extract this particular element. Okay, we'll change this particular element because extracting is very simple. We'll change this particular element 0.99 whatever it is by specifying where it is, and then equal to will change it to suppose 999. And now what if we print it? See, the value is being changed. Here it was 0.999. Okay, it was 0.99. Wait, I'll change the value. 666. It's very confusing otherwise. Sorry. Now it is 666. lock display. Now just we don't want to know all this data frame again and again. We don't want all of this. Since we've changed the first element, it should be visible in head, so we will just insert head. I just want to see the above data which contains my changed data. Now what if I want to access the specific data? Here we change the specific data. Now I want to access the specific amount of data. So for that we will use another code, which is, let's say I want to access these two row and say CD columns. Okay, we can access whatever we want, we just need to specify it in the code. So we'll write df.loc. Now 1 comma 2. This specifies my rows, the rows which I want. Now name, not the number, not the index number. It specifies the name of the rows that I want. Okay, I'm getting some error over here. Name of the index 1, 2 data type object are in the index. Okay, I shouldn't have used this parenthesis, it was just this much. See, so we don't use curly brackets, round brackets over there. We just use the square brackets. So here we are able to access first and second, 1 and 2 row names and C and D column names. Now what if I tweak this a little bit? I want all the rows but specific columns. So for that we will use new df.log. Now we will specify in a certain way. Now since you want all the rows, we'll use colon instead of mentioning all the row names. We'll just mention colon over there. So colon, then we want the same column names, C and C and D. So this should give me all the columns and all the rows and specific columns. See, here I have all the rows and specific columns. Now what if I want to do this in reverse? Like I want all the columns and specific rows. We'll just use a similar thing over here. Instead of putting column over here, we'll mention which all rows we want. Suppose 1 and 2. 1 and 2. And here we will change it to colon since we want all the columns. So here see, it has given me first and second 1 and 2 rows and all the columns, A, B, C, D, E, all the columns. So this is how log function works. We name we access it through the names of rows and columns, not through the index numbers. Now we'll use ilog function. We'll access first specific element of this of the data frame through ilog. That will use name df.ilog. We'll specify which data we want. Suppose we want 0 and this data. So this index number is 0 and 0. A's index number is 0, B's is 1, C's is 2, and D's is 3 and E is 4. So I want to access this particular element. So the data, the index number should be 0, 4. Now let's see if this gives me 0.3061. 0.3061 over here. So the index number is 0 and the index number for column is 4. So 0 and 4. 0 and 4 index number I've used over here. So yes. And then I want columns also and rows also. So I'll have to mention the index numbers of columns also and rows also again. New df dot I log. Now I want okay 0 5 and then 1 and 2. So this means that I'm asking pandas to give me the value of 0 and 5th row and 1 and 2, like first and second column. First and second doesn't mean that first column. Column starts with 0. So first means the one that comes after, which is B. So it'll give me B and C. Now let's see if it gives me C. It has given me B and C in place of column since 0, 1, 2. B has column number, index number 1 and C has index number 2 and index number for rows as 0 and 5. Now we'll import a CSV file. Since until now we've been making data frames, now we will import data frame. I already have this data frame, so I'll just write df1, which will be the name of my data frame, then pd dot read csv. This is the code for reading any CSV file. Now I have this bank list 11.csv. I'm using this file. Okay, I've got an error. No such file or directory. banklist.csv. Okay, it seems that I don't have this. I'll check it once. So you go here, banklist, you check it. I have it. Now what could be the problem? I'll go check the name. I think I didn't try the name properly, maybe. You have to be very specific when it comes to name. Okay, let's move this a piece. Okay, there was a space. I wrote banklist 1.1. You cannot do it like that. Whatever name of your file is, you have to name that specific letters, arrangement of letters, whatever you have named your file as. Now we will go with the practical application. Now what if your boss comes and asks you that I want this specific information from this data frame. Now use your Panda, use your Python and give me all that information that I need. So here our boss is asked, it seems that give me the column names of this data. So the data frame might have a lot of column names. Here we'll just have a look at the data frame that I have used here. So we have a lot of column names. Okay, bank name, cities, ST, cert, etc, etc. So to get the column names, I'll just use this function, which it is very basic functions over here. But the practical application, like how would you use this easy function to get the answer of a complex question, is where your knowledge actually should apply. So here I'll just use df1, which is the name of my data frame, and then dot columns. As simple as that. So this will give me an index of bank name, city, ST, etc, etc. All these are the column names. Okay, this will be used, like, since in this data frame also I have very limited name of columns. But what if I have 334 columns? So in that case I'll need a gist of all the column names. Okay, so in that case it will be very helpful. Now shape function. Shape function enables us to have a look of the data frame, as we use in matrices. Like we have 30x24 name of the data frame, which means that we have this number of rows and this number of columns. So I'll just go ahead and write df1 dot shape. Let's see what it gives. So 551 comma 7. This means that we have 551 rows and 7 columns. This gives you a gist of your data frame. And then last is unique function. This finds the unique values from a series, like whichever specific series in your data frame you want. It will give you all the specific or unique values it has. So here let's just go back. Which series would I want? Okay, this seems to be a little easy. So we'll use ST. ST means state, like which state does the bank belongs to. So for that we will use this function in df. Now to specify which series I am actually referring it to, I'll have to mention it in square brackets, and here also I have to use the same name which is there in my data. I cannot use state instead of st. If it's there in my data as st, capital St, I cannot use any other word, not even small st or anything. I'll have to use the same thing. Now to use this function, I'll use unique, and then I'll use this. Here it has given me different types, like all the different values of state which was used. Now in this data frame I might have like repeating names, like here it is IL, here it is IL, here again it is IL. So it won't give me like number of IL, it will give me the unique values that are in this series. So now to summarize everything, we have covered following topics: how to form a series, then type function, how to ascertain which type this data frame or series belongs to. Then forming a data frame, we have formed two data frames, I guess. Then how to form a CSV in this Python. Then head function, tail function, which basically gives the overview of the few top rows and columns, and tail gives the output of few last bottom columns and rows. Then describe functions, which basically describes the few statistical analysis of your data. It works only with numerical values. Index function, data type function, dtype. Sort function, we use it to sort our data frame. Log function, we have already recently learned about it. Log function is label based. ilog function is position based, which is basically index based. Then column function, shape function, and unique function. So with this, I'll end my video. Thank you very much to watch this video, and I hope you learned a lot from this. Thank you.